Hi everyone, welcome back to my third tutorial. In this part, we'll continue developing a Bitcoin trading bot, but this time instead of doing trades randomly, we'll use the power of reinforcement learning. So the purpose of previous and this tutorial is to experiment with the state-of-the-art deep reinforcement learning to see if we can create a profitable Bitcoin trading bot. There are many articles on the internet that says that neural networks can beat the market. However, recent advances in the field have shown that reinforcement learning agents are often capable of learning much more than supervised learning agents within the same problem domain. For this reason, I'm writing these tutorials to experiment if it's possible, and if it is, how profitable we can make these trading bots. While I won't be creating anything quite as impressive as OpenAI AI engineers do, it's still not an easy task to trade a Bitcoin profitably on a day-to-day basis and do it in a profit, actually. We have to create a plan up to this point. So before moving forward, I'll cover what we must do to achieve this goal to create a Bitcoin trading agent. So at first, we had to create a custom trading environment, what I did in my first tutorial actually. So then I had to create a simple and elegant visualization of the environment. And third, what I'm actually writing in this tutorial, train our reinforcement learning agent to learn profitable trading. Well, actually, this is the current. I already have a draft of this tutorial in text version, so actually everything is quite fine. If you are not familiar already with the previous tutorials, not so long ago I have written them, and on both of these topics, feel free to pause here and read either of those before continuing with this third tutorial, because actually I'm doing this everything step by step. So for this tutorial, I'm going to use the same market data history that I used in my previous tutorials. And if you missed where I got it, I actually got it from bitcoincharts.com. And of course, I'll add a link in my text version tutorial so you could easily find it, or I'll upload to my GitHub. Actually, I already did. Here is the full code of this tutorial, and if there will be any mistakes, I'll fix them, but I hope I finished already the code. And actually, you can get everything here. The link will be on my text version tutorial or YouTube description link. So let's get started. While writing code in this tutorial, I thought that for people who are beginners in Python might be hard with required libraries. So actually what I decided that I need to add a requirements file to my GitHub repository, so people would know what packages they need to install. So if you clone my code before testing it, make sure to run a pip install and actually all these libraries. I think this is all I need for this tutorial. Actually, when you install all these libraries, you can move forward. I would like to say that this third actual tutorial part will require the least custom programming creativity. I already have programmed everything we need in the past. I simply need to merge two different codes with small modifications. Actually, if you were following me, I already wrote and tested a proximal policy optimization tutorial. I have it here with Lunar Lander v2. So I will need to pick that code and merge it with my previous tutorial code, actually with second part I already have also here, and you can find it also on my GitHub. Here is the second part. If you are not familiar with proximal policy optimization, I recommend reading my previous Lunar Lander v2 tutorials. This will help you to form an idea of what we are doing here. Actually, differently from my previous tutorial, now I'll define my model architecture in another file, and this will be called model.py, and already have it. So I simply copied actual model and critic model classes to the following file from my Where is my GitHub? Actually, I'll open, and I hear all the tutorials here. and here is my bipedal walker and lunar lander, and here it is. And I have here a different classes, actor model and critic, and actually I copied them to this file. So actually at first I add all necessary imports that are required to build our actor and critic models. So mainly this is only a TensorFlow and NumPy imports, and here I disable eager execution that my model would work faster and there wouldn't be any misunderstandings. I'm not going to explain here how the proximal policy optimization model works, as I said, because that's already covered in my past tutorials. But you might notice one difference in code. Instead of doing actually, let me compare this. Instead of doing x equal to dense as it is here, I here use a flattened layer because input shape is 3D of shape of 1, 150 and 10 actually, and our dense layer doesn't understand this, so I use a flattened layer which gives me a concatenated array of shape this kinda, and this is the value our model will try to learn from. And I'll remove this. Okay, coming back to my main script, there are also many upgrades. I'll going back here. First of all, on existing imports, I add 3 more. So this is TensorBoard X and TensorFlow Keras optimizations. And actually, this is our actor model and critic model I import from our new models.py file. TensorBoard X will be used to our TensorBoard logs. You might use it or not, it's up to you, but sometimes it's useful. Next, for our experimentations, I import Adam and RMS prop optimizers, so we could change the experiment with different optimizers from the main script. And lastly, I'll import our newly created actor and critic classes, as I said. Also, in the main this part of our custom environment class in init part, I add actually this part. I rename it, actually this is the new part. I rename it that it would be called neural networks part below. Here I define a learning rate, training epochs, and chosen optimizer for our neural networks. Also here I define a normalization scaling value that is typically recommended and sometimes very important, especially for neural networks. Normalization can be very crucial because when we input unnormalized inputs to activation function, we can get stuck in a very flat region in the domain and might not learn at all. Or worse, we end up with numerical issues. I will need to get deeper into this normalization stuff later, but now I will use the value of 100,000 because I know that there are no bigger numbers in my dataset. In the best case, we would use normalization values between minimal and maximum, but what if our future market high get bigger than had in our history? Actually, with normalization, I have more questions than answers that I will need to answer in the future. Now I'll use this hard-coded normalization, as you see this number. Also, in this place, we create our actor and critic classes in this way that will do all the hard work for us. The replay counter and writer are simply used for our TensorBoard. Logging stuff, well, actually nothing so important. Next, moving further, I copied our replay. Where's my replay, act, save, load, and get G's functions. All of them didn't change except the replay function. At the end of it, I added 3 lines I used for my TensorBoard writer to log our actor and critic losses. Also, I forgot to mention that into the reset function, I added a SelfEpisode Orders parameter. Where it is, reset. This one, which I use in the step function. Every time our agent does sell or buy orders, I increment this parameter by 1. Well, I use this parameter to track how many orders the agent does through one episode of learning. We'll see later why I do that. And actually, I think let's move to the training part. I think this part is one of the most weighted. How actually we train this agent to do profitable trades in the market, you might ask. Usually, every newcomer to reinforcement learning doesn't know how to actually train their agent to solve their problem, domain problem, in a concrete environment. So I recommend to start from simple problems and do small steps while trying to more difficult environments by getting better scores. So this is the reason why I implemented a random trading in my first tutorial. Well, actually, I began all this stuff, well, with all this my tutorial list. Well, actually, I began from card poll, and actually I covered a lot of different strategies of reinforcement learning to learn more about it, so I would know how to implement this. Now I can use it to build on top of these actually implementations. So actually here is the code I implemented and the train agent. Actually here it is. I'm not going to explain the training part step by step. If you want to understand all steps here, that's a lot what I need to say. So I recommend to check my reinforcement learning tutorials I showed you in a moment, but I will give you a short notices. Actually, this is something new. I use these lines to plot our net worth, average, and how many orders our agent does through an episode. So these lines are helping me to see how my agent is learning different stuff. And also, instead of saving our model, this is the part, every step, I track the best average score our model could achieve through 100 episodes and save only the best one. Well, I'm not sure if it's a good evaluation method of our model, but we'll see later if it is. Maybe I'll get a better idea as how to do that. Next is the test agent. Testing the agent is just as important as training, or even more relevant, so we need to know how to test our agent. Actually, test agent function is very similar to our random games agent. If you would compare, there are only two major differences: that at the beginning of the function we load our trained model weights, this part, and if you would see in random there is no such loading. And second, instead of making random actions as they were did here, actions, and I use a random here, I here use an prediction with our model. That's it. I don't want to waste the time, so let's begin the fun part, and I'll call it a training part. One of the biggest mistakes I found others do while writing market prediction scripts, they do not split the data into a training set and test set. I think that's obvious that the model will perform nicely on scene data. The purpose of splitting the dataset into training and testing is to test the accuracy of our final model on fresh data it has never seen before. Since we are using time series data, we don't have many options when it comes to cross-validation. For example, one common form of cross-validation is called key-fold validation, in which data is split into key equal groups and one by one single out group as the test group, and the rest of the data is used as a training group. However, time series data is highly time dependent, meaning later data is highly dependent on previous data. So key-fold won't work because our agent will learn from future data before having to trade it. That's an unfair advantage. So we are left with simply taking a slice of the full data frame Actually, I can move below. Here it is. Use that training set from the beginning of the frame up to the same arbitrary index and using the rest of the data as the test set. As you can see here, I actually chose it to use last 30 days as testing data and rest of the data set as a training. And you can see that since our environment is only set up to handle a single data frame, we are creating two environments. One for training data and one for the test data. Actually, this is here. And now training our model is as simple as creating an agent with our environment and calling it in above created actually function train agent. As you can see here, I can call a train agent script and this would be training it. But first, I'm not going to train because I already trained it. I would like to simply show you the results. So I'll comment this. And I'm not sure how long I should train it, but I chose to train it for 20,000 steps. And let's see how our training process looked like in Tensorboard. So here it is, the repository of my folders, and open the terminal here and I'll write something like Tensorboard and it will be logged there and runs. Here will be saved all our Tensorboard logs. So I'll open it and this is the link. I'll copy it and open the browser and let's see. I'll open it and this is the whole history. I'll zoom it out for you so you could see it better. I'll use a smoothing parameter here. So actually you can see my Tensorboard results while I was training our agent for 30k training episodes. I'm 100% sure we can say yes, our agent was learning something, but it's quite hard to tell what. As you can see, it's fine that actor loss goes up here and critic loss goes down here. Stabilizes through time, but one of the most interesting charts for me is episode orders and average net worth that are on the right side of this Tensorboard. We can see that yes, our average net worth goes up, but only by a few percents from initial balance. As you can see here is the somewhere below is our initial balance of 1,000. I think started one from 1,000. So this is something like $1,030 actually in average, or 40. It's quite similar, but that's only a few percent from initial balance, but still that's a profit. And this graph tells us that our agent is learning. And as you can see, agent thought that it's better to do fewer orders than more at one moment while it was learning, because at the beginning it was doing 160 orders and it was going down, down, down. And even at one moment it thought that, well, maybe we could simply hold the balance. This would be the best. But sometimes there were training batches where the trend was totally down, so our agent went to the loss, and well, actually then they thought, okay, we still need to do some kind of orders, and it still learned that it needs to do something to survive or to get a profit. And actually I wanted to answer for myself from these charts, can our agent learn something? And the answer is totally yes, it can. And that was my goal of this tutorial. Now I can show you how my agent performs on this unseen data, actually, this test agent. And I'll run it. It should work and it should give me some kind of visualization. Here it is. And it's rendering. And I'm not sure how to explain everything because this is on one example and there are much more examples how my agent works. And actually you can clone my repository and simply you'll see how everything works. I did this kind of testings to evaluate our agent and to check if it can beat a random agent. From 1000 episode steps with the following 2 commands. So this is the way how I evaluated if our neural networks actually learning something and if we can improve it or something like this. So I did a comparison with a random agent, and actually I don't have results here right now to show you, but what I can say that my random agent did $1,024 in average, and this was $1,044 actually. And considering this average profit of our agent was made in actually these 30 days, called 1 month, 4% sounds like a quite nice results. The only reason why our random agent also got a nice profit, I think because our train was up in this testing dataset. But also seeing my trading agent here in this kind of lift rendering chart, I noticed that agent just after selling all open positions, it quickly opens another buy. As you can see, here is sell, here is buy, here is sell, buy, sell, buy, sell, buy, gap, sell, buy, sell, buy. And this would never lead us to a good profit, so we'll need to analyze and solve this problem. And I think this is something correlates with our reward system. I'll try to analyze this problem in depth, I think, future tutorial. So actually, this was quite a long tutorial, and I would like to stop here. We achieved our goal to create a profitable Bitcoin trading agent from scratch using deep reinforcement learning. That could be the market, and we already accomplished 4 steps. So we created a Bitcoin trading environment from scratch, built a rendering of this quite beautiful environment visualizations. We trained and tested our agent with unseen data. As you can see, we're actually doing this right now, and actually we are quite satisfied with our results because it performed a little better than a random agent and made some kind of profits. And while our trading agent isn't quite as profitable as we'd hoped, it is definitely getting somewhere. I'm not sure what I'll try to do in the next article or tutorial, but I'm sure that I'll test some different reward strategies. Maybe we'll do some kind of model optimizations, but we all know that we must get better profits on unseen data. So I'll work on it actually. So this is the end of this tutorial, and everything is on my GitHub. Thank you all for watching, reading my tutorials, and as always, all the code given is in the tutorial and can be found on my GitHub page and is free to use. Well, so thank you again. Subscribe me, like, share, and help me to live. Actually, help others to see my tutorials. Actually, there was a 1 episode, as you can see right now, and there was $30 in profit, and we made 156 orders through an episode. Moving back to the end, all of these tutorials are for educational purposes and should not be taken as trading advice. You should not trade based on my algorithms or trading defined in this previous or future tutorials, as you're likely to use your investment. So thank you again. Thank you all for watching. So see you in the next part of this tutorial series. Goodbye and see you there.